Okay, so hey everybody, welcome back. For this week, we'll be talking about social cognition. And as usual, it seems best to start with just a straightforward definition. So when we're talking about social cognition, what we really mean is a theoretical perspective that is interested in how people interpret, analyze, remember, and ultimately use social information. So a couple things worth highlighting in this definition. The first is the idea that social cognition is a theoretical perspective. So what this means is that social cognition isn't a specific research area or topic within social psychology. Instead, social cognitive principles get applied to many different areas or many different aspects of social cognition. So that actually means that the readings in this mini lecture this week are pretty important going forward in the semester, because a lot of these basic ideas of social cognition tend to reoccur. So when we start talking about prejudice and stereotyping, for instance, social cognition is very important there. When we talk about attitudes, a lot of the research on attitudes is social cognitive, meaning that it adopts this theoretical perspective that we're going to talk about today. So these key principles that come up in the reading this week and that I'll discuss here in our lecture are things that you will see again throughout the semester. So probably the biggest part of this social cognitive perspective that people will use when studying all sorts of stuff in social psychology is the distinction between what are usually called implicit and explicit cognitive acts. So the basic idea here is that we can think, and we can use and interpret information about the social world in two different ways. We can basically think automatically, right? We can fly on autopilot without thinking very hard or expending much energy or effort. Or instead, we can think in more effortful, controlled ways. And this is the distinction between implicit and explicit cognition, or automatic and controlled thinking. So I want to give a nice demonstration of this, and it's probably something you've seen before, maybe in a cognition class. And it's the Stroop test. So if you're familiar with the Stroop test, the way it works is it's a timed task, and you see words that are color words, like blue, green, yellow, pink, red, orange. The catch is that these words are printed in a color that's different from the word itself. So you see that blue is printed in red and green is printed in blue. And if you try to read these words really quickly, it's actually kind of challenging. It's especially hard if I ask you to say the color that the word is printed in and not to just read the word. So right, to do that, if you look at blue, you'd have to say red, and you have to do it quickly. And for green, you have to say blue, because it's printed in blue. And go ahead, give it a shot yourself. You'll see that this is actually pretty difficult. And this is the Stroop test, is what it's called. And the Stroop test actually shows the difference between using implicit and explicit cognition. So just reading the words, just saying blue, green, yellow, pink, red, orange, that's essentially an automatic process for me. And anybody that's an experienced reader, if you see words, you read them automatically without trying. It's just effortless. However, when I all of a sudden ask you not to just read the word anymore, but to say the color it's printed in, that gets a lot harder. And the reason for that is that just saying the word, just reading it, blue, green, yellow, that's using automatic, effortless, implicit cognition. And you can do that all day long. You'll never get tired of it. But when I ask you to say what color the word is printed in, that requires explicit cognition. You have to think hard about it. And you have to override your automatic, implicit tendency to just read the word. Right? So you have to sort of push down or try to kind of stamp out that very easy reflexive tendency to just read the word, and you have to replace it with this much more effortful, explicit cognitive task of saying what color the word is printed in. And the idea that just reading the word, just saying blue, green, yellow, is really easy is because implicit cognition, these automatic cognitive acts, are effortless. They're no trouble for us. But it is so hard to instead say the color that the word is printed in, right? To say red, blue, green, as I try to go across. That is so hard and so much slower because explicit or controlled cognition requires effort. So if you want a nice analogy for how this works, imagine you're visiting a friend and they live in Manhattan, and let's say they are on the 10th floor of an apartment building, and you've got two ways to get up to the 10th floor. You can take a walk up the stairs, or you can take the elevator. And generally speaking, which of these two will most people choose? Usually people will choose the elevator. And the reason for this is that it's quicker and it's effortless. So why don't people want to walk 10 flights up the stairs? Well, it's slow, right? The elevator will get you there quicker than the stairs. And also, walking up those stairs is going to tire you out. It's going to take a lot more effort than just taking the elevator. And this is a nice way to think about explicit and implicit cognition. Taking that long, effortful walk up the stairs, that's explicit cognition. It's thinking hard. It's exerting a lot of mental energy. Taking the elevator, that's an analogy for implicit cognition. It's fast and it's virtually effortless. It's really, really easy. So now a consequence of this is that, generally speaking, when possible, people will take the easiest route. This applies to taking the elevator instead of the stairs in most cases, but it also applies to using implicit cognition whenever we can. So because people rely on implicit or automatic thinking so regularly, I just want to sort of spend a couple of minutes going over some of the defining features of what it means to think automatically or implicitly. All right, so one key aspect of implicit cognition is that it's non-conscious. It means that we aren't necessarily aware of our automatic cognitive processes. Another really important thing is that automatic cognition is involuntary, meaning that it just happens. So if you think again about reading, as soon as you see words, you start reading them. You don't have to tell yourself to start. As soon as they appear in front of you, it just happens. You begin to read them. Implicit or automatic cognition is effortless. It's easy. Once something has become automatic for you, it's something that you can now do on autopilot, right? Without thinking about it, without having to make it, without having to try to start it. It is simply effortless. And automatic or implicit cognition is rapid. It occurs very quickly. And because of all of these features, right, because of these defining characteristics, the fact that automatic cognition is involuntary, effortless, it's quick, this is why people will rely on implicit cognition if they can. Because it's simply easier and faster than thinking hard. And this idea that people will rely on implicit cognition when they can, and will very rarely use explicit cognitive resources, unless they have to, this has a name within social psychology. It gives rise to the concept of the cognitive miser. And if you think about it, a miser is someone who is cheap. This is someone who doesn't want to spend money if they don't have to. So when you apply that word of being a miser or being miserly to cognition, what it means is that we don't want to spend our cognitive resources if we don't have to. If we don't have to think hard about something, we usually won't. We will rely on this low effort, very fast implicit cognition whenever we can get away with it. An important concept that's related to this idea of automaticity and how people will rely on this automatic low-effort cognition if they can is a schema. So in the simplest terms, a schema is an organized structure of knowledge. So it's basically this big interconnected web of information that we have in our head. And we have pretty elaborate, well-developed schemas for things that we know a lot about. So, for instance, if you play chess, you know a lot about chess. You have a really well-developed schema that includes the rules of the game, the objectives. It includes the names of all the pieces, but if you're a really good chess player, your schema also includes things like opening strategies, the best moves to make at certain points of the game, when to take risks and move your queen out, something like that. So we have these schemas for all sorts of things, including for people and for groups of people. So when we talk about stereotypes later in the semester, keep this definition of schemas in mind, because schemas, because stereotypes are just schemas, really. They're structures of information that we have about groups of people. They might be wildly inaccurate, but they're still schemas. So I want to just provide you with a visual representation of a. So imagine that you have a schema about elephants, right? And so I say elephant, and this will activate. It will bring to mind your schema, everything you know, or at least think you know, about elephants. And these schemas are contained in memory. Right? So all this information that you have about elephants is just kept in your long-term memory. And when I say elephant, it activates, it brings to mind, or primes your schema about elephants. And when that happens, all this information in your head that is related to the construct elephant will pop into your head, right? It will become activated as well. So I say elephants, and you probably start to think about their appearance. They've got a trunk, they're really big, they're gray and wrinkly. You might think, oh, they live in zoos, and they're kind of similar to things like giraffes and tigers. They at least share a similar environment. But then maybe other stuff pops into your head as well, right? So elephants are the symbol of the Republican Party. And then when you think of Republicans, perhaps you think of one of the Bush presidents. Elephants like peanuts, and this might remind you of peanut butter, for instance. So this is how schemas work, right? They're all this information that's connected in this web, essentially, in your head. And when schemas are activated, all of this information that's normally just stored kind of dormant in long-term memory will become accessible. It will be made available to you. So it's important to consider that schemas do lots of important things for us. Once a schema becomes activated, they play an important role in our social cognition. So one thing that schemas do for us is they help us understand the world around us. So if you go back to the lecture that I posted last week, I talked a little bit about top-down and bottom-up perception, and schemas relate to that. So schemas allow us to understand things in a top-down manner. Schemas are built on prior experience. So if you know a lot about chess, you have a chess schema. If you know a lot about elephants, you have an elephant schema. And once those schemas are activated, this now becomes a context that helps you understand incoming information. So here's for you. If I show you this picture, what's going on? They're getting married, right? You didn't need any words, you didn't need any, verbal labels or anything. You saw the picture and you understood that it was two people who were getting married. And once you see this picture, your schema for weddings becomes activated. So everything you know about weddings, the script that they usually tend to follow, the sequence of events, there's a ceremony, and then there's a reception afterwards. If you're lucky, it's open bar. These are good things, right? We understand how weddings work. So, right, you have a schema for a wedding. So you see this picture, that schema becomes activated, and it helps you understand the picture that you're looking at. So now the way that you encode and interpret this information is very different than if I show you this picture. And if I show you this couple, what are they doing? It's a lot less clear. And the answer is they're also getting married. They are in traditional Mongolian wedding attire. But even now that I've told you that, you don't really have a schema for how a Mongolian wedding traditionally plays out. So because of that, it's hard to interpret what's happening in this picture. We can't really understand what happened before the wedding. We don't understand what's going to happen after they get married. Is there a reception? If there is, what does it look like? So this is one example where having schemas can in one case be very helpful. When I show you a picture of a sort of traditional Western American wedding, your schema for weddings is activated and it lets you understand the picture that you're looking at. But in the case of a traditional Mongolian wedding, the absence of a schema, even when I show you a picture and tell you they're getting married, you can't really quite understand the social situation nearly as well. So this is one example of what schemas can do for us, is they actually provide something of a top-down context to let us make sense of the world around us. And this relates to the idea of automatic thinking, because when a schema becomes activated, as soon as you see that picture of, a Western American wedding, everything you know about weddings just automatically, effortlessly, involuntarily becomes activated. It just gets switched on in your head. And because of that, you don't have to think very hard about the picture you're looking at. You just understand it somewhat naturally. However, for instance, a traditional Mongolian wedding, the fact that you don't have an elaborate or well-developed schema for it means that you have to think a little bit harder to make sense of this picture, right? You have to engage in more explicit, more effortful cognition to understand a traditional Mongolian wedding. So this is one way in which schemas play an important role in automatic thinking. They let us understand and efficiently encode the world around us, and they let us do it in a way that doesn't require effortful thought. So to build on this idea of schemas a little bit, I threw around a couple of important terms earlier when we were talking about schemas for elephants, for instance. And one of them I said was that when I say elephant, your schema for elephants becomes accessible. And when concepts are accessible, like schemas, what this means is basically that they're ready to be used. So when a schema is accessible, that means it's right there at the top or the forefront of your mind. And when things are highly accessible, they're likely to be used. We will use an accessible schema to encode and interpret and understand the world around us. And lots of experiments are done that intentionally activate schemas. And this process of making a schema accessible is known as priming. And I posted up on Blackboard, in the same spot where you found the link for this lecture, a video of it's a TV recreation of a very well-known priming study. And what happened in this study, and the video kind of runs you through the procedure, is participants had their schema of the elderly activated. And if you think about the elderly, now that I've just said it, I have primed you. I've primed you to think about old people. So when you think about the elderly, what kind of stuff comes to mind? Perhaps things like characteristic behaviors, like the fact that the elderly are kind of slow-moving. And that's one part of your schema for this group of people, for the elderly. And if this stereotype, if this schema about the elderly is primed, if it's made accessible, this can have implications not only for how people understand and interpret the world, but it actually spills over into our behavior. So in the video that I posted, which I encourage you to watch, it's only like 5 minutes long, participants are primed with these thoughts of the elderly. Their schema for the elderly is made accessible. And interestingly enough, this influences their behavior. It actually leads people to walk more slowly than they normally would. So they start walking in a manner consistent with what is on their mind, with what kind of schema has been made accessible. So it demonstrates that when schemas are highly accessible, we use them not only to interpret the world around us, to help us understand things, but they also get used in more behavioral ways. They actually change how we act. So it's a pretty powerful demonstration of how priming works and how schemas can be made accessible. And an important thing to note about priming effects, and your textbook goes through a few examples as well, is that they occur without our conscious awareness. So oftentimes when participants are primed, it happens in a way that's very subtle. It's kind of sly, so they don't know that a particular schema is being made accessible, but it still ends up influencing how they interpret information or even how they behave. Aside from schemas, there are some other important cognitive devices or cognitive things that get used that allow people to rely on low-effort, implicit cognition as much as possible. And one example are what are known as cognitive heuristics. And heuristics are shortcuts. And these are mental shortcuts, or rules of thumb, that people are especially inclined to use when they have to make a complex judgment. And why people will use heuristics is the same reason that we'll use shortcuts at any other time in life. It's because they get us to a destination faster. So if we solve a problem using a heuristic, it basically means we are taking a cheap and easy shortcut. Now, a problem with heuristics, and your textbook goes through a bunch of examples of this, especially with representativeness and availability heuristics, so I encourage you to read that material, it's helpful. Right? One problem with heuristics is that they don't always provide us with the correct answer. They usually work well enough. But because heuristics are efficient but ultimately kind of cheap and low-effort problem-solving strategies, this means that sometimes they can lead us astray. And if you really want to get a problem right, sometimes this requires explicit, effortful, conscious cognition. And when we engage in this explicit mode of problem solving, we're usually using what's known as algorithms. And these are effortful, complex problem solving strategies that are based on formal rules. So to provide a concrete example of this, if I gave you a math problem like 312 plus 415, if you went through the math of solving that, and it is 727. If you went through the problem of solving that by writing out the problem and actually doing the math, well, you definitely got the right answer, probably. But it was a little bit effortful. It took you a little bit of time to solve it. You applied an algorithm. You used the formal rules of math to solve the problem. But if it wasn't absolutely essential that you get the correct answer, if you wanted a good enough solution, you could just round that off. You could say 312 is about 300, 415 is about 400, the answer is close to 700. And if you did that, it's faster and it's easier, but it's a heuristic. It's getting you an answer that's probably in the ballpark, but it's not necessarily precise. And like I said, your textbook talks a lot about two heuristics in particular, availability and representativeness heuristics. And these matter in social contexts. They are important social cognitive quirks, essentially. So just to sort of play out one example, this availability heuristic is based on how easy it is to think of examples of something. And the more easily we can think of examples of things, the more often we believe it happens. Which is why people overestimate the danger of flying on airplanes, because when planes crash, it's a huge news story for days. And this makes it easy to think of instances of planes falling from the sky, which makes people overestimate how often it happens. But, of course, driving is in fact much more dangerous than flying. Right? Car accidents are far more frequent than are plane crashes. But nevertheless, people overestimate the danger of flying, in part because of the availability heuristic. In more social contexts, availability matters as well. So one thing that tends to happen if you have a roommate or if you live with a significant other is you might feel like you do 70% of the housework. And why? Maybe you do, but if that's not actually the case, if housework is in fact split 50-50, people will still think they do more of it than their roommate or their significant other. And that's because of this availability heuristic. It is really easy to bring to mind every time you do the dishes or take out the trash. But oftentimes, when your roommate or significant other does these things, you don't see it. So, because examples of your roommate doing the dishes aren't easily available, right? They're just not stored in memory because you didn't even see it happen. Because they're not available, they're not easy to bring to mind. But all the times you did the dishes, those instances are available to you. You can remember them easily. And this leads people to overestimate how often they do the dishes. And this can lead to discord between roommates or, romantic partners. So these heuristics matter. They have real social implications. But aside from what's in the textbook, let me show you one other interesting recent piece of research that shows heuristics in action. So, if you remember, part of that definition on the last slide was that heuristics get used to reduce a complex decision, to make a really difficult decision kind of simple. And this is why we will use a cognitive shortcut. Right? It just takes less effort. So, as one example that was done in a recent study, real, actual, honest-to-God human resource employees were given a chance to look at job candidates' resumes. And while they looked at them on a computer screen, where they looked was tracked using eye tracking technology, which basically records where people look on a computer screen so you can see what they're gazing at, which is a really nice way of measuring what are people paying attention to. And selecting a job applicant, looking through a big stack of resumes, that's a complex decision. And to do it really, really carefully would require a lot of explicit, very effortful cognition. So as you can imagine, human resource managers, just like anyone else in the world, they're cognitive misers. They would like to reduce this very effortful, complex decision of hiring someone to as simple a process as they can. And to do that, they're going to apply some heuristics. And this use of heuristics was demonstrated really nicely in this research. So what they did is they had these human resource managers look at, I believe, 100 resumes. And that's a lot. It's a lot of information to take in. And what they found from tracking their gaze, well, one important finding was that they looked at the resumes on average for 10 seconds. So 10 seconds is not a lot of time to encode a whole bunch of information about a person. So what kinds of information were these human resource managers looking for? Well, what they looked at in these 10 seconds was, where did someone go to school, and what degrees did they have? Were they currently employed, or were they not? And if they did have a job currently, what was their title? And why are these the three pieces of information that get glanced over in 10 seconds? Because they all provide heuristic cues to an applicant's quality. Right? Did they go to a really good school? And if so, did they have a bachelor's degree? Did they have an MBA? That's something that you just want to look at really quick if you're a human resource manager, if you're looking over these applicants to make hiring or firing decisions. Right? Because knowing where someone went to school, it's a shortcut, but it's one very quick, kind of cheap and easy way to evaluate the quality of their resume. Is, where did they go to school? What training do they have? The next thing was, are they currently employed? And if the answer to that question is no, in many instances, the resumes get tossed. So it's a way of simplifying this decision. Is this person currently working? Yes or no? And then if they are currently working, what are they doing? Well, why is this important? What's their current title? This is important because, again, it's a sort of heuristic value. It's a shortcut that you can use to evaluate someone's application for a job. You can look at their current title, and if they are a chief financial officer, in their current employment, wow, all right, like they have real authority, genuine, managerial responsibilities. That's heuristically a good sign. If they're an unpaid intern, maybe that's a little less impressive. Now, the important thing about this is that these heuristics, none of them are guaranteed to get you the right answer. It's entirely possible that the perfect candidate, someone who's really, really ambitious, who's highly skilled and would do a great job, it's entirely possible that they're going to get filtered out when people in a human resources office use these heuristics, right? Maybe they didn't go to a great school, maybe they are currently unemployed, and those are just bad breaks. Maybe they're going to be a great candidate, but when these heuristics get applied, they basically become a filter. And the reason that someone will use heuristics when evaluating 100 resumes is because it reduces this very, very difficult, very complex decision to something much simpler that takes a lot less time than going carefully through 100 different resumes. So this is just this recent study that came out is just one very nice, practical, real-world example of how heuristics can get used. So we just saw one very real-world instance where heuristics tend to be used. But there are other times in our life where we are inclined to use shortcuts. And frankly, the use of heuristics is very commonplace because people are cognitive misers. We want to conserve our energy if we can. And this applies to physical energy usually just as much as it does mental energy. So because of this, heuristics get used pretty commonly. But I just want to enumerate some specific instances that make using heuristics especially likely. So one of them is when we have to make decisions or arrive at some conclusion quickly. So remember, one advantage of implicit or automatic cognition is that it's quick. It's much quicker than explicit cognition. So if we have to think fast, we're likely to use heuristics. They're a shortcut. And if we don't have a lot of time, a shortcut is very appealing. We'll also use heuristics if we are simply overloaded with information. And this relates to the example I just went through with human resource employees looking through resumes. When you've got 100 people applying for one job opening, wading through those 100 applications is overbearing. You just, not only do you really not have the time for it, but just the sheer amount of information is overwhelming. And in these cases, to help us deal with such a tremendously burdensome amount of information, we'll apply heuristics, because they reduce the incredible complexity that we're dealing with to something much simpler, much more easily managed. So if you think about it, when a human resource employee is going through 100 resumes and they apply these simple, these kind of quick and dirty heuristics, where did you go to school? What are you doing now? When these get applied, that is probably an efficient way to reduce 100 job applicants down to a short list of 10 who you want to interview. And once you've done that, once you've made 100 applicants a much smaller pile of 10, now you're not overloaded with information anymore. And for those final 10 candidates, well, now you can evaluate their resume much more effortfully using explicit cognition. You won't use heuristics really anymore. And you can start spending more mental energy thinking about these last 10 job applicants. But before you could get to that place, before you could get to that stage, you had to use some heuristics simply to get through the overwhelming amount of information you had. So if you remember with the math example that I gave, one consequence of using heuristics is that they don't always get you the right answer. They can lead you astray sometimes. So one instance where we're willing to use heuristics and basically just solve problems the cheapest way we can is if we're solving a problem that isn't very important to us. So if something isn't that important to us, if we're not motivated, we're not going to engage in explicit cognition. We will use all of the sort of low-effort, automatic, implicit processes that we can. So if something's not important to us, we're happy to use heuristics. And one other circumstance where heuristics tend to come in handy is if we simply have no idea how to solve a problem. So if I gave you a math problem that was amazingly complex, it wasn't just simple addition, but it was some just incredibly like high-level, matrix algebra kind of stuff, and you just didn't have the background to solve that problem, it wouldn't be worth your time or energy to engage in explicit cognition. It just wouldn't be worth thinking hard about solving the problem because you're never going to get the answer anyway. So you might as well just take whatever shortcuts you can and make your best guess. So in circumstances where we just don't know what to do with ourselves, or we have very little knowledge that can help us solve a problem or make a decision, in those instances we're happy to rely on heuristics. So one last thing that I want to talk about here is how expectations, specifically about other people, can have really powerful impact on our interactions with others. So a classic example of this is what's known as the self-fulfilling prophecy, or more technically, a behavioral confirmation effect. And this is another case where I've posted a video up on Blackboard that you can find the link to it in the same place you downloaded this lecture. And it demonstrates a self-fulfilling prophecy in an educational context. So I encourage you to check out the video. I think it helps make this concept really clear. I'll run you through the steps of how this self-fulfilling prophecy works. So in last week's discussion, in several instances, people brought up Rate My Professor. And Rate My Professor is obviously an interesting source of information for a variety of reasons. But it's something that students use when it comes to setting their course schedule every semester. You find if you're teaching a class, you look them up on Rate My Professor, and you see what their ratings are. So you can imagine a circumstance where you take a professor, and their ratings aren't great. But they're the only person offering the class that semester, and you have to take it. So you sign up for it, and you're going to have to deal with it. But you're going to go into the semester with certain expectations about the professor. And entering a social interaction with an expectation about the person you're going to interact with, that is step one in bringing about a self-fulfilling prophecy. And then the next step is that your expectations about a person